Welcome to all of you. Myself Sudarshan, Assistant Professor in Computer Science Department in St. Martin Engineering College. Today my topics are error correction and detection in computer networks. Okay, in computer networks, we are classifying into 7 layers for the communication purpose. It's developed by the International Standard Organization ISO in 1984. Okay, here the lowest layer for the lowest layer, physical layer, next data link layer, in network layer, in fourth layer, transport layer, and fifth layer, uh, session layer, in sixth layer, presentation layer, last layer, application layer. Okay, here the error correction and detection comes under the two layers. One is data link layer, another one is transport layer. Okay, in the data link layer, here we are classifying into the three parts. One is header, another one is trailer, another one is data. We classify into the three parts. One is header and trailer and data and trailer. Okay, in the header field it contains of source port address and destination port address. Using that we have to find out the particular packet in the networks. Okay, in the trailer field it deal with the error correction and error detection. Okay, here next in generally it should be happen in the during transmission. Here in reliable connection we cannot using for this, we cannot use for the errors. Okay, here in generally it represent only for the data link layer and transport layer. Next in generally the error occurs in the two field. Okay, one is a single bit error, another one is burst error. The error should be happen only for the two. One is single bit, another one is burst error. Here one is single bit, another one is burst error. Single bit, it should be happen only for the one bit. If you changing, if I am sending the data 1000 like that. Okay, if the receiver side it getting the if we getting any one change, it called as single bit error. Okay, in burst error, you come to the burst error. If you have to change two or more bits, it called as burst error. Let me tell one example. Okay, this one for sender side, this one for the receiver side. I am sending the data 00000010. Okay, 000010. Here instead of 0 at the receiver side, I am getting 1. Instead of 0, the change with 1. It called as single bit error. Okay, in burst error, okay, here I am sending the data 01000100100011. If I am sending the data, if I am getting the receiver side, if I am getting two or more bit changes, okay, instead of 0, I am changing 1. Instead of 0, it's changing 1. Instead of 0, changing 1. Like that, if I am getting more number of bit changes, is called as burst error. Okay. Next error detection. Generally, in error detection, it happen used for the parity. Okay. If I am sending the data to the receiver side, in receiver that didn't send any acknowledgement, okay, it called as error. Okay, here we are using for the error detection using redundancy, that called as parity bit. Using that redundancy, we have to calculate with the calculate the errors in the receiver side. Okay, how to calculate the parity bit? The one formula is there. I will tell you the formula. Okay, one formula: 2 power r greater than or equal to 2 power r greater than or equal to m plus r plus 1, m plus r plus 1, m plus r plus 1. Here 2 power r, 2 power r, 2 power r greater than or equal to m plus, listen, m plus r plus 1. Here m represent as a bits, number of bits you have to take. Okay, r represent as redundancy bit plus 1. Just you have to substitute one by one. Okay, r equal to 1. Just you have to take r equal to 1. So 2 power 1. 2 power 1 greater than or equal to my message size. You have to take some message. I have to take 1010. I have to take 1010 my message. Okay, here the 4 bit. The message size is 4 bit. M equal to 4. Just write it here. M equal to 4. Here 4 plus R redundancy bit 1, okay. 4 plus 1 plus 1 5 6, okay. 6 greater than or equal to 2, that condition is true false. So again you have to substitute with the R equal to 2, again you have to substitute with the R equal to 2. Here R equal to 2, here 2 power 2 greater than or equal to 4 plus R plus 1, okay. 4 plus R plus 1, 4 plus R plus 1, you are getting the value for 4 6 7 7 to 4 greater than or equal to 7, that condition is false. So again you have to substitute with the R equal to 3, R equal to 3, or if you have to take the R equal to 3, my R 2 cube 8 greater than or equal to 4 plus 3 plus 1 8, so 8 greater than or equal to 8, the condition is true. So you have to take redundant bit 0, the redundant bit should be apart with the original message. Here I am taking 1010 plus redundant bit 3 bits, okay. You have to take 3 bits. Next, the error should be occurred only for the reliable communication. Reliable communication, what is a reliable communication? In reliable communication is nothing but, if I am sending the data, the both sender and receiver should have to use the same constant rate, okay, that called as a reliable communication, okay. Next, redundancy. Redundancy means adding extra bit. Redundancy is nothing but adding extra bit with your data. If I am sending the data 1010, so in that data we have to append with the extra 3 bits or 4 bits or n bits, okay. Next, this is an example for the redundancy. If I am taking the data 10100000010101, this is my data, okay. Here generating function, what is the generating function? Here the error detection, it mainly used for the 4 methods. One is LRC, VRC, CRC, checksum, okay. Once completed generating function, either you have to use any techniques, okay. After that, generating the parity, the parities are using any one. If I am taking LRC technique, okay, it generates the parity 1011101. So it append with the original data. At the receiver side, checking function is there, okay. In checking function, we have to use it for checking function any kind of algorithm, okay, and can check either it may be 0 or 1. If 0 means accepted, 1 means rejected, okay. This one for the redundancy. So in redundancy, how can I check the redundancy? Okay, how can I check? I will show one video. You can easy to understand. How can I check the redundancy? How can I check the redundancy? It is an extra bit only. In redundancy, it is an extra bit only. Using that, we have to find out the redundancy. This one for the CD drive. In CD drive, the stored collection of information stored in the zeros and ones. If it isn't cracked, okay, here this one for the error, okay, this one for the error. Initially we have to use it for the encoding and decoding, okay. In the encoding, what is mean by decode and encode? In encryption, decryption is nothing but convert the plain text into ciphertext. In decryption is nothing but convert the ciphertext into the plain text. If you are using some type of algorithm, here if you are using this encryption decryption, we have to record some keys. One is asymmetric key, another one is symmetric key. In symmetric key is nothing but at the both side we are using for the same key. Example, public key, okay. At the encryption, at the decryption, we are using for the same key, okay. For going for the asymmetric key, we are using for the different keys. Either it may be sender side, you are using for the public key. At the receiver side, you are using for the private key, okay. The 2 key we are using, okay. Next, this one for the encoder, decoder. After decoding, getting the correct images, okay. Next, this one for the encoder. Here they had me apply in the file or music or pictures. We can apply either all things, okay. This is my original data. the original data should be appended with a redundancy bit. You can redundancy, you can add 2 or more copies. Here I have to add 2 copies. Okay, here the original data, if I am sending to the receiver, the original data and redundancy. If I am sending to the receiver check whether it is in 0, there is no error. Whether it is in 1, it is in error. Whether it is in 1, it is in error. 0 means non-error. 0 means non-error. Okay. For encryption and decryption only we are using for the 2 key. Okay. Next, here these are the techniques we are using for the error detection. VRC is nothing but vertical redundancy check. VRC is nothing but vertical redundancy check, and CRC is nothing but cyclic redundancy check. CRC is nothing but cyclic redundancy check. LRC is nothing but longitudinal redundancy check. Longitudinal redundancy check, and checksum is nothing but it is the way of find out the error detection method. Let me discuss one by one. Okay. Let me discuss one by one. Here first LRC. LRC is nothing but longitudinal redundancy check. Longitudinal redundancy check, it only focused on the even parity. It not focused on the odd parity. It only focused on the even parity. If it is in odd numbers, it converted to the even parity. Okay. If I am sending the data 1001, if I am sending the data 1001, you check the count the number of ones. Check the number of ones. Okay. If it is in even, just add 0. Okay. It is in least expensive technique. It is in least expensive technique. If it is in even, just add 0. If it is in odd, add 1. Okay. Here let me discuss one example with the vertical redundancy check. This is my checking function at the receiver side. This is my data. Okay. This is my data. This is my data 001. Okay. First you check whether it is in even or not. How to check whether it is even or not? First count the number of ones. 1, 2, 3. 3 ones are there. So this one for the odd numbers. Okay. Just the even parity generated in the sender side, it generate the 1. If it is an odd, it generate 1. In append with the original data, at the receiver side checking function is there. So in receiver side check whether it is even or not. It should be accept only for the even. Okay. At the receiver should accept only for the even function. Okay. At the receiver side. Next, one example. One example, my data 11101110. Okay. I am sending the data 110110. Here 1101111. Okay. Next, third data 1110010. Okay. After adding the parity, how to check the parity? Here just count the number of ones. Here count the number of ones. 1, 2, 3, 4, 5. 5 ones are there. It is in odd numbers. So you have to add the 1 even or make it as even. Just have the 1, add the 1 parity. Okay. Just next number 1, 2, 3, 4, 5, 6. This one for the even. So that's why we are add the here 0 here. If it is an even number, should add with the 0. If it is an odd number, should add with the 1 like that. Okay. Here 1, 2, 3, 4. This one for the even parity. So that's why we add the parity last 0 in the data last. Okay. Next, if it check only for the even and the odd. Okay. In longitudinal redundancy check, it mainly used for the organized in rows and columns. Okay. Based on the column, we have to calculate the every parity. Okay. Based on the column only, we have to calculate the parity. How to calculate the parity? Here, this one for my data. First, my data is 111001111, and again 1101101 and 001110011 10101001. This is my data. First, you should have to organize with rows and columns. Okay. Here first data, second data, third data, fourth data. Here first data, in second data, in third data, in fourth data. Okay. Here first you have to add the count the number of ones. Here 1, 2, 3, 4. It is in even numbers. So it is in even. So you have to add 0 here. Okay. Next count number of ones. Here only one, this one for the odd, so you have to add the one parity here. Okay, next count 1 2, so 2 is a even parity, so you add the 0 here. Next here 1 1 1, it is in odd number, so you have to add 1 here. Okay, like that we have to do like that. After that, find out the parity for the LRC. Find out the parity. The parity should be append with your original data and send to the receiver side. In receiver side, how to check the errors. Okay, this one for the sender side, done by only for the sender side. And the receiver side, if I am getting the data with the parity, how to check whether it is an error free. Okay, how to check? First you have to write here data one by one. Okay, 1 1, here my data 1 1 1 0 0 1 1 1, my first data. Okay, my second data 1 1 0 1 1 1 0 1, my second data. My third data 0 0 1 1 1 0 0 1, my third data. My fourth data are 1 0 1 0 1 0 1 0 1 0 0 1, my fourth data. Okay, just add with the parity. What is my parity bit here? 1 0 1 0 1 0 1 0 1 0 1 0 1 0, this is my parity bit. Okay, this is my parity bit. Just you have to again count the number of ones. This one for the even parity, so even numbers, so you have to add with the 0 here. Okay, here this one for the second one, here 1 here 1, this one for the even, again you have to add 0 here. You go for the third one, 1 1, it is an even, so add 0 here. This one for the even, add 0. This one for the even, add 0. This one for the even, add 0. Like that, this one for the even, add 0. This one for the even, add 0. Okay, finally getting the receiver side, all are 0. See, here all are 0. If it is 0, if it is 0, they will be accepted. Okay, if you getting the receiver side 1, it will be rejected. Okay, once I am sending the data should be arranged in the row and column. So calculate the count the number of ones. Okay, if it is in odd number, add first one priority. Okay, if it is in even, add 0. Okay, the sender should be append with the original data and sent to the receiver side. Receiver side check, add again to add all the numbers, total number of ones. If it is in even, add 0. Finally getting the all zeros. If it is 0, that should be accepted. If you getting any 1, it is in error. If error means the sender should resend the particular data. Again reset the particular data. Okay, for next CRC. In CRC is nothing but cyclic redundancy check. Here in the CRC we are using for the data and parity at divided by some divisor. Okay, using for the divisor we have to divide whether it is in error free or not. Okay, first one by one. First let me discuss one by one example. Okay, first this one for my data. Okay, we are using for the divisor, I am getting the CRC code. Okay, this one for the data, I am using the divisor, I am getting the CRC code. The CRC code should be appended with your data. At the receiver side, using the same divisor, you getting the some reminder, right? So you check the reminder, either it may be 0, accepted, non-zero, rejected. Okay, next one example. So I am taking the value 100 this is my value. Okay, here my divisor, what is my divisor? 1101 is the divisor. So if I am taking 4 bits, I have to add 3 parity. If I am taking 4 bit divisor, I am add 3 parity in loss of data. Okay, if I am taking 5 parity, 5 bits, I am taking I have to append with the 4 parity. Okay, like that, if I am taking the 4, so append with the 3 parity 0 0 0. Just divide one by one. Here 1101 1101. So I getting the value here. What is the value? 0. I am getting the value for 0 1 0 0. Okay, I am getting the value for here 0. Here 0. I am getting 0 0 1 1. Binary addition, you can do binary addition 0 0 0 1 1 0, like that. Okay, so Here, if you're getting the first zero, if you're getting the first zero, you have to reject that one. You have to reject that one. So remaining numbers 100. So you can take 0 from here. Okay, again you have to devise 1101. So again 110, 011, 000, 011. So if you're getting the 0 in first, you have to reject. So again you can take the 0 from here. Okay, again you have to devise 1101. So what is the value? 110, 011, 101, 011. So you have to reject that one. So you have to take the 0 from here. Here again you have to devise 1101. Okay, 1101. What is the value? Here 110, 110. Okay, you're getting the value for 110, 110. Here 101, 011. So here you're getting 20. Previously you're getting 10. You have to reject. Now you're getting for the 2 zeros. Okay, so you have to reject 2 zeros. Okay, again you have to take the 0 here and 0 here. Okay, again do the divisor. So 1101. So 110, 110, 000, 011. You're getting the value for 0001. But I am taking only for 3 numbers. If I am getting the result 0001, but I am taking only for the 001. Why? Because I am taking only for the 3 parity bits. I am taking only for the 3 parity. So that's why I am taking for the last 3 numbers. Okay, last 3 numbers. At the receiver side, this is done by the sender side. At the receiver side, what will happen? Here the data plus the parity. Data plus the parity. Okay, what is my data? Actual data 100100. What is my parity? Append with the parity bit 001. Okay, in the receiver, check the same divisor. Using the same divisor, divide the numbers once again. Okay, if you're getting this remainder 0, it will be accepted. There is no error. Okay, if you're getting any ones, it is an error. Okay, at the receiver side, the same process. What is my parity? Finally, I am getting the center side 001. It appended with the original data. The same divisor we are using for the same divisor. Okay, you can use the same divisor here. 110. You're getting 0, right? So you have to remove that 0 here. 0, you have to remove that 0. Again 011, 000, 110. Okay, you can take the 0 from the here. Okay, again you have to divide the same number 1101. What is the value? 0, 1, 0, 1. Again you can remove the 0 here. Again you can take the 0 from the here. Again the same procedure 1101. What is the value? 110, 011, 101, 011. Here you can remove the 0. You can take 0 from the here. Again same 1101 divisor. So here 110, 110. You're getting the value for 110, 110. So you have to remove the 0 from the here. Okay, you can take the 0 from the here, and like that we have to repeat the step. Finally you're getting the remainder. Okay, finally you're getting the remainder 000. If you do like that, 110, 110, 0, 110. Finally you're getting the 0. If your remainder is 0, if the remainder is 0, it should be accepted. Okay, if the remainder, if you're getting 1, it is an error. If it is an error. Okay, so this one for the CRC. CRC is nothing but cyclic redundancy check. Using the data should be appended with the parity. Using the divisor, you have to calculate whether it is an error or not. Okay, next checksum. In checksum, it done by the in center side, it checksum's generator is there. At the receiver side, checker is there. Using that, we have to find out whether it is an error or not. Okay, here detect the error. In example, checksum, this one for the example. In first of all, if I am sending the data, entire data, okay, it segregates some segments. Here, what is my segment? First segment 100, 11001, 100, 11001, 11001. My second segments are 111, 00010. My second segment. Third segments are 00, 100, 100. Third segment. In fourth segments are 100, 00, 100. Four segments. Okay, here first you have to take with k equal to 4. Why? Because here I am using only for the 4 segments. Okay, m equal to 8. Why I am taking m equal to 8? Here I am taking 8 bit. Okay, first is center side. What will happen? First you have to add with the 2 numbers. First segment, second segment. Here what is my first segment? 100110001, my first segment. Again another segment, second segment. What is my second segment? Okay, in second segment 1110010, my second segment. Okay, just you have to add this one. Okay, add this one 101. Okay, 011. Okay, 000 101 101 011 011 and 110, remainder 1. Okay, you carry 1. The carry should be added with this sum. Okay, again you have to add. Okay, what is the value? 110, 110, remainder 1. Here carry 1, here 110, here 1, 1111, like that you getting. Okay, next my third data, the sum of the value is appended with the third data. Okay, what is my third data? 00100 00100 So it should be just calculated here 000 110 101, here 10110, the remainder carry 110, here like that we can do the addition. Okay, what is my value here? 101010. The sum of the value should be added with the next data. For next data 100 100 100. Okay, if you getting the any carry, just add with the next segment. Okay, finally you getting the, what is the finally getting value? Here 00 100 101. Okay, after finally getting the sum value, you do the ones complement. Okay, you do the ones complement. Instead of 1 you can change 0, instead of 0 you can change 1, like that you can do this. Done by the sender side. First add all the data field. Okay, if you getting any carry, add with the particular sum. Finally you getting the sum value, do ones complement. What is the receiver side? What happened in the receiver side? Okay, here the receiver side, the same procedure. Okay, what is the value? 1100 11001, here 111 00010. The same thing you have to add up to here the same. Okay, up to here the same. The last we have to add the checksum value. This one for the checksum value. The checksum value added with the particular sum. Finally you just calculated 01. Here finally you have to calculate 101 1011. Here like that we have to calculate it. Finally you do the ones complement here. Okay, ones complement. One, if you getting the 1, instead of 1 you can change 0, all are 0. Okay, here this one for the conclusion. Here if it is in 0 it is accepted, if it not 0 the rejected. Okay, not 0, rejected. In error correction, okay, in the error correction we are using for the Hamming code. In error detection we are using for the 4 method in LRC, BRC, CRC and checksum. Okay, in error correction we are using for the Hamming code method. Okay, using that Hamming code, first you have to find out the parity. Okay, the parity should be appended with the data. We have to find out the parity. What is the formula for the parity? 2 power r greater than or equal to m plus r plus 1. Okay, thank you, sir.